Okay, so we looked briefly at this last class, but let's have another look at it. Writing an equation given a graph. So remember, when we're writing the equation, we are looking for a vertical stretch, a horizontal stretch, a horizontal shift, and a vertical shift. So we kind of went through a few steps the other day about perhaps the best order to find things. So the first thing I'm going to find is the middle, which is also called the sinusoidal axis. So if you remember, we can find the middle by just finding the average between the top and the bottom. So on this graph, the top is at 6 and the bottom is at -2. And so that gives us a middle of 2. So I'm going to draw that on my graph because everything is based from the middle, not from the x-axis. So I can see that this is my vertical shift, right? The graph has been moved up 2. So that's my b value. Okay, so vertical shift is 2. The second thing I would look for is the amplitude. So as mentioned previously, you could either count from the graph, right? Now that I know where the middle is, I can count 1, 2, 3, 4 to the top, or 1, 2, 3, 4 to the bottom. So I can see that my amplitude is 4. So you could just count. If you want to kind of double check to find the amplitude, you can take the top minus the bottom. So we're taking the difference between the maximum and the minimum and dividing by 2. So that also gives us the amplitude. So the amplitude is 4. Okay. Then we would look to find the horizontal stretch or compression. Right, so this is my C value. So if you remember, the C is going to be the normal period, which is 2 pi, and then we're going to divide that by the period of this graph. It does not, just keep in mind that your x-axis does not have to be measured in pi. This one is just in numbers. For example, if we're measuring time, then my x-axis units are not going to be measured in pi. They would be measured in seconds. So it's not necessary that it's in terms of pi. This graph has a period. Let's see. So I might go from here to here. That's start and end of a cycle. I could go from top to top. I could go from bottom to bottom. Whatever's easiest to read. So this has a period of 8 units, whatever those units might be. I'll just put period equals 8. So I can see that this is 10, so this is 8. So the period is 8. And then we would just reduce that to pi over 4. So that's my C value, and that's the value that goes in the equation. So the 8 is not the number that goes in the equation, it's the transformation, which is C. All right, so now we can start putting the equation together. So the amplitude is 4. I'm going to do it in sine first. The C value is pi over 4, and the vertical shift, is up 2. So now all I have to look at is this, where does sine start? Well, in this graph, sine is starting exactly where it should start at 0, 0. So there is no horizontal shift with the sine curve. So I would just say sine pi over 4x. So it has not shifted left or right. If I were to do cosine, so amplitude stays the same, C value stays the same, vertical shift stays the same. The starting point for cosine is normally at the top of the curve, which is here. So the sine or the cosine curve has been shifted, the starting point to the right, 2 units. I'm just counting on So I'm measuring from the red line in the middle, so it's 2 units to the right. So cosine would be shifted right 2. You could go left, but usually we go in the positive direction, and I can't see the left anyway, so we'll just stick with the right. So that is my equation in terms of sine and in terms of cosine. The only difference will be the horizontal shift. Everything should stay the same for both equations. Okay, this question is in your guide, so we'll just run through a few questions in the guide, and then we'll add a Ferris wheel question. So in this question, they not only give us a graph, but they also give us an equation. Okay, so I'm just going to write the equation out at the bottom here because it's quite small. So it's written like this. You could write it with the 20 at the end, right? If you want to sort of keep it in A, F, C, minus, if you kind of want to keep it in the same form, then the 20 is the vertical shift, right? So I'll just put that at the end just for convenience sake. So question A says, how far above the ground is your foot at time 0? So this is the cycle. If you're riding a bike and your foot is on the pedal, so think of a wheel, right, with a pedal, and your foot's on the pedal and you're going around, right? You're pedaling. So it creates a nice trigonometric curve. So how far above the ground is your foot at time 0? So I could either look on the graph, so it's obviously at 5, right? That's at time 0. Or if I were to use the equation, I'm looking for my height at time 0. So I'm going to put in t, time, as 0. Well, cosine of 2 pi times 0 is 0. And then if I think of my value of cosine at 0, think of the cosine curve at 0. Cosine is 1. So cosine of 0 has a value of 1. And then negative 15 plus 20 is 5. So I get the same answer whether I use the equation or whether I'm just seeing if there's any units here, centimeters, so 5 centimeters. So whether I use the equation or whether I look on the graph, I'm going to get the same result. It's 5 on the graph. This is in seconds and this is in centimeters. Or I could put 0 into the equation and end up with the same answer. Okay, B says, what is the amplitude of this function? Well, the amplitude is the a value, so from the equation I can see it's 15. From the graph I could see, well, this is 20 and this is 5, so I can see from the graph it's also 15. So I can read it either from the graph or from the equation. And then it says, explain why the radius must be 15. Well, the radius is also the amplitude. Right? If you have a bike and your foot is on the pedal in the middle, then it's going down to the bottom and up to the top. So the radius is also the amplitude. Okay. How far is the center above the ground? Well, that's the middle at 20. So again, I could see that from the graph, right? I can see it's at 20 up here, or in the equation, it's the vertical shift, right? So I can see from here, it's 20. So I'll just write here, it's also the vertical shift, or you can look on the diagram. And then E, what is the period? Well, I'm going to use the equation for this one because it doesn't have any scales on my graph. There's no numbers on the x-axis, so I'm just going to use the equation. So the period is 2 pi divided by c, right? 2 pi is the normal period. And then I'll divide by the c value in the equation. Well, the c value is 2 pi. So that equals 1. So that means it takes 1 second to go around to pedal around once. And then how long does it take to make one rotation? Well, that's the same answer. 1 second, right? So the period is the time it takes to go around the wheel once. So that would be the same as one rotation. So that question is really just useful to make sure you understand how the graph and the equation relate to each other. What information can I get from the equation and how can I see that on the graph? Okay. This one is also from your guide, same page. So you have a water wheel. So I'm going to sketch this. I always like to have a visual of what, there is no equation given. It's going to ask me to find an equation. So I'm going to sketch this graph. So it says a water wheel with radius 7 has 1 meter submerged. So if this is my height in meters, the bottom is 1 meter below, so I'll put -1. And then the radius is 7. So from the bottom, I'm going to go up 7 to the middle, and then up another 7 to the top. So the middle would be at 6 meters, which is 7 meters above the bottom. So that's the only numbers I need on my vertical axis. I need the bottom, the middle, and the top. On the x-axis, which is time, so you can do time in 2 ways. This one says the wheel rotates at 6 revolutions per hour. So we could do it in minutes or hours. If I do it in minutes, and either answer is fine, so it's 6 revolutions per hour or per 60 minutes. So 1 revolution would be 10 minutes, right? 60 divided by 6. So I'm going to do mine in minutes, and then I'll show you the difference in the equation. So I'm going to do it in 10 minutes. I'm going to divide that in half and then in quarters. Right, so my one cycle we want to divide into 4 equal increments. So divide in half and then divide again. So 10 minutes to go around once. And then it says time is measured when point P on the rim is at the maximum height. So it's telling me to start my graph at the top. Then we go to the middle, down to the bottom, back to the middle, back to the top, and there's 1 cycle. And then it would just repeat. Okay, so that's a sketch of the graph with the distance above the surface of the water. So now B wants us to determine an equation. Okay, so what do we know? We know the amplitude. The amplitude is the same as the radius. It is 7. I'm going to do cosine first because it looks like cosine, right? So it looks like a cosine curve that starts at the top. That means I don't have to do any horizontal shifts, so I'm just going to do cosine. And then the vertical shift is up 6. Remember, that's the middle, not the bottom. A lot of times I have some students write the bottom, but it's actually the middle, right? The vertical shift. And then C is, so I'll do it 2 ways. C is 2 pi divided by the period. So if we do it in minutes, as I did the graph, then it was 10 minutes. So that reduces to pi over 5. Okay, so I'll just say pi over 5t plus 6. So there's one option. If you do it in hours, like they did in the guide, so if you look at the answers in the guide, they have their final solution or final equation in hours. So C is 2 pi over period. But if I'm doing it in hours, it said 6 revolutions per hour. So 1 revolution would be 1/6 of an hour. Okay? So if I keep it in hours, it would be 1/6 of an hour. So 2 pi divided by 1/6 is 2 pi times 6, which is 12 pi. So that's fine too. If you want to do it in hours, it's perfectly fine. So this one's in minutes, and then this one's in hours. So I could also say 7 cosine 12 pi 12 pi t plus 6 if I were doing it in hours. Okay, so either one's fine. Both are acceptable. If I was doing sine, well, sine starts at 0, 0, right from the middle. So sine normally would look like this, but it's over here. This is the middle going up. So this sine has shifted all the way over to here at 7.5. Okay, so you could do sine if you want. I would just do cosine because it looks like cosine, but sine is okay. But then you would have to have a shift to the right 7.5. Right? That's a 0.5. So either one's okay. You can have the equation in terms of minutes, in terms of hours, or you could have it in terms of sine. All right. So if there's any questions, I don't see anything. Okay. Ferris wheel question is quite common. We have a radius of 12 meters. It goes once around every 36 seconds. At the bottom, the passenger is 1 meters off the ground. I want you to draw 2 cycles and then write an equation depending on whether we start at a different spot. Okay, so I'm just going to sketch a graph. So time is in seconds. Height is in meters. Okay, so on my height, I only need 3 numbers, the bottom, the middle, and the top. The bottom is 1 meter off the ground. The radius is 12 meters. So from the bottom, I'm going up 12 to the middle and up 12 to the top. That's all I need on my graph. The bottom at 1, radius is 12, so add 12 and then add 12 again. So here's my middle of my graph. It says that 1 rotation takes 36 seconds. It wants me to draw 2, so we'll go to 72. We'll cut that in half, so 18, and then cut it again into quarters. So this is 27, 36, 45, 54. I'm just going to do that number. And then it says, first of all, draw it starting at the bottom. So I'm going to start at the bottom, go to the middle, up to the top, back to the middle, down to the bottom. There's 1 cycle. And then I'm just going to repeat. There's 2 cycles. Okay, so this is an equation starting at the bottom. So we have a couple of different options. I'm going to do it in sine first. So the amplitude is the same as the radius, 12. I'm going to do it in sine. My c is 2 pi divided by the period. The period of this graph is 36 seconds, so we're going to reduce that to pi over 18. And the vertical shift, or the middle, is at 13. Okay, so from here I'm doing sine. Sine starts at the middle and goes up. So here's sine, the start of sine. So it's shifted to the right 9 seconds. So we'll put -9 for sine. If I were doing cosine, cosine starts at the top. So that's shifted to the right 18 seconds. So if I were doing cosine, everything would stay the same except the horizontal shift is now to the right 9 seconds. Okay, so that would be in terms of cosine. And then we also mentioned last time that we could do a vertical reflection for cosine, knowing that cosine starts at the top. If I flip it over, it starts at the bottom. So I could do a vertical reflection with the amplitude for cosine, and then not worry about a horizontal shift, just a vertical shift. So those are my 3 options for sine and cosine. Okay. The second part says, what if we started the graph at the middle of the Ferris wheel? So I've got the same 3 numbers, 1, 13, and 25. I'll just do 1 cycle, so 36. And here's the middle. And then we're just going to start it at the middle of the graph. So middle, top, middle, bottom, middle. There's 1 cycle. So if I were doing sine, well, sine looks like it is. It looks like exactly like a sine curve. So if I did sine, amplitude is 12. Sine, we've got pi over 18. No shift, no horizontal shift, and then up 13. If I were doing cosine, the cosine starts at the top, so that's been shifted to the right 9 seconds. Okay, so that would be if I started it at a different spot. All right. Okay, I'm going to leave this one up here for a second. I'm going to mute myself and do the attendance, and then you can try this one and see how you make out and see if you're understanding what we're doing. Okay, let's see how we made out with this one. So we have radius of 45 and center is 50. So sometimes it'll be worded in a different way. It might not say the bottom's here. It might say the radius, it might say the diameter, it might say where the middle is. So it'll be described in various ways. So it says the middle is at 50, right? The center is 50 above the ground. The radius is 45. So that means from the middle, I'm going to go down 45. So that would take me to 5, and up 45 would take me to 95. And this is in meters. The Ferris wheel makes 1 rotation in 20 seconds. So I'm just going to do 1 rotation. And we'll cut that in half and then cut it again. So those are my important parts of the axes. And then it says, suppose the graph starts when the rider is at the lowest height. So we're going to start at the bottom, go to the middle, back to the top, back to the middle, down to the bottom. So there's 1 cycle. Right, they're pretty easy to draw. And then we'll write our equation in terms of sine and cosine. So I'll do cosine first. Well, let's do sine first. So the amplitude's 45, right? We know that's the radius, and we can also see from the graph the amplitude is 45. I'm going to do sine. And I know the vertical shift is 50 because that's where the middle is. I need to calculate C. So C is 2 pi divided by the period. The period is 10 seconds, so we'll reduce that to, 20 seconds. So we'll reduce that to pi over 10. And then the beginning of sine is normally here. It's shifted to here. So it's normally at 0, 0 on the middle of the axis. It's now at 5 to the right. So we'll shift it 5 to the right. If it's cosine, the only difference with cosine is where it starts. Cosine starts at the top. So that's been shifted to the right 10. So everything else should stay the same if I use cosine. So radius of 45, cosine, C value stays the same. It's shifted right 10 and up 50, or we could also do that vertical reflection with cosine. and then we don't have to do a horizontal shift. Right? So any of those three options would be the ones that I would use. Remember, it is continuous, so you could, shift it to the second cycle to the right, but normally we go to the right. The closest shift, we would not go to the left because the left would mean negative time, and that does not make sense that we would have negative time. So my options would be to the right, the closest one, or a vertical reflection. And then at some point it might say, find the height of the rider at 12 seconds into the ride. Then you would just put that number in for your time and then just type it into the calculator to find the height. Okay, are there any questions there?